Hello everyone and welcome back. In this video I am going to talk about stoichiometry and the ideal gas law. And the main thing that I'm going to talk about is how we can use this roadmap that I've been talking about, the one that I've called the chemistry conversion superhighway. Um, so this is the main road that you're on. So we've been building off of this. So we've learned that we can use the molar mass to convert between moles or mass and moles of one substance. And remember, the stoichiometry is where you are using a balanced equation of a reaction to help you convert from uh, the amount of one substance to the amount of another substance. And so that's the hub of stoichiometry. And so if we use our molar mass to convert between mass and moles, and we can use our mole ratio from the balanced equation to convert between moles of one thing and moles of the other, and then we can get to moles of B. So the A and B are the different substances that we're converting from and to. And so in stoichiometry, we're always going to have a balanced equation. Um, so in we've been building off of this. So in an earlier chapter, we learned to use molarity as a conversion factor. And so you now these are like kind of off roads to the main highway, right? So you're on a side road here. So if you're giving the molarity, then you can use it as a conversion factor to convert liters. This is like a solution. So let me write that down, solution. So if you got liters of a solution, then you can use, if you know the molarity, or you have some way of finding the molarity, then you can use that as a conversion factor to go from liters of solution A to moles. And then once you've got moles, you can now use the balanced equation to convert from moles of A to moles of B, whatever that is. And depending on where the problem wants you to end, it might want you to end at a certain number of grams, so you use the molar mass to convert, or it might ask you to give you another volume of this other substance, and so you would need the molarity of that other substance to do that. So we've done this so you can go from the side road onto the highway, onto the side road. We've dealt with problems where the liters, they wanted milliliters of the substance, so there's an extra step here. Um, but this is what we've been building off of. Now, in chapter 6, you will be dealing with the ideal gas law, or gas laws in general. And so if we know the conditions of the gas, so a lot of reactions are going to have gaseous reactants and products and things like that. So the ideal gas law is going to come into play. So now we can use the ideal gas law to help us convert. So in this case, we'll have some liters of a gas or milliliters of a gas, and to get onto this roadmap, we need to get into either mass or moles. But because the ideal gas law has moles in there, we can use the information given to us. So a lot of times they're going to give us liters or some volume of a gas, and then they're going to give us other conditions of the gas, pressure and temperature. And so we can then use that. If we recognize that we're given that information, we can then use the liters and the other conditions, pressure and temperature, put it into the ideal gas law, and then we can find moles. And then once we have moles, we can go wherever we want, depending on what the problem is asking for. So again, if we want to convert to B, we need to then use the mole ratio of the balanced equation. Because it's stoichiometry, we need a balanced equation. And then once we get moles of B, we can go wherever we want based on whatever the problem is asking for. So again, if they're asking for moles, then we stop here. If they're asking for mass in grams, then we stop here. We need to convert from moles of B to mass of B using the molar mass of B. And then maybe they want the mass in milligrams or micrograms, whatever it is. So that'll be an extra step. But a lot of times they'll ask for the moles of a gas that's in a product, right? So we'll have to use the ideal gas law again, the conditions of the gas. Now the conditions are going to be the same because a reaction is under the same conditions. So any reactant that's reacting, if it's a gas, is going to react under the same conditions that any product that is formed because it's in the same container, same vessel. So the pressure and temperature of a reaction is going to be the same here and here. And so with that, you can convert using the ideal gas law and pressure and temperature, you can convert from moles to liters of the gas. And again, if they want milliliters of the gas, then you will convert to that. Or if they want atmospheres of the gas, or if they want something, whatever it is that they want, you can use ideal gas law to convert to that. But most of the time, you're going to be looking for the volume. So this is how you can use the ideal gas law and use stoichiometry to basically solve a problem, figuring out how much of one thing do you need for another, or how much product is formed if you start with a certain amount of reactant, or how much reactant do you need if you want a certain amount of product. And also keep in mind limiting reactant problems. You always have to look at your problem to make sure that it is not, or it is, a limiting reactant problem. And so, so when you look at a limiting reactant problem, you want to look at to see, okay, did they give you two amounts of something, or did they give you information of the two reactants reacting together? And did they say something along the lines of it's in excess of, or it reacts completely with, or something like that? If they give you that sort of terms, if you're looking out for those terms like reacting completely, or it is in excess of, or something along those lines, then you know it's not a limiting reagent. But if they just throw information at you, if they just say, okay, we have this much of substance A and we have this much of substance B, how much product is formed, or whatever, then if that's all they give you, then you know it's going to be a limiting reagent problem, or at least you should check to make sure it's not a limiting reagent problem, and then you follow that. If it is a limiting reagent problem, then you gotta go with the whatever reactant gives you the least amount of product, and then go from there. So always be on the lookout for limiting reagent problems. They don't go away. Okay, that's it for this video. I hope you found it interesting. So if you like this video, go ahead and like the video up here, wherever it is. Subscribe to the video, share the video, make a comment in the comment section, and let me know what else you would like to know about. Thank you for joining me. I'm Mr. Kowalt, and see you next time.